Sinusoidal functions. You guys are going to learn about the properties of trig functions and how to graph them and write them. This is what you guys would have gotten to had we not gone on quarantine last year, because usually that fourth quarter is when you start learning about the unit circle and you start learning about the graphs of sine and cosine. You don't necessarily, for this course, you don't have to know the unit circle. The circle is in your packet, but like I said, you don't necessarily have to know every piece of the unit circle. There are 5 main pieces though that you do need to know. So the unit circle is called the unit circle because it is a circle that's inside of a coordinate plane with an x and y axis, and it has a radius of 1. Any angle that's in your unit circle has what's called an initial side on the positive x-axis, and then its terminal side is basically the other side of the angle that creates the angle, okay? When you head in a counterclockwise fashion, you create a positive angle. Now, the pieces on the unit circle that you need to know for this class are your quadrantal angles. They are your angles that lie on each of the axes. Since our initial side starts here on the positive x-axis, that is 0 degrees. Here on the positive y-axis, how much of the circle have I gone? 90 degrees. Very good. And then if I go half the circle, I'm on the negative x-axis, which is how many degrees? 180 degrees. Very good. This one not 360, but 270 is three quarters of a circle.
Miss Anderson?
Yes.
So you said that it's going negative, but why wouldn't you put negative 180?
No. It's going positive when it goes counterclockwise.
Okay.
Yeah, it's going positive when it goes counterclockwise. If it goes clockwise, then you have negative angles. So once I've gone all the way around, I end back up here, but I'm not at 0 degrees. I'm actually where? 360, because I've gone a 1 complete circle. So 0 degrees and 360 degrees, they lie in the same location. It's just after you've gone a full rotation. These are the main angles that you need to know in order to graph these different sinusoidal functions and also apply and work with them, okay? So, knowing that, the unit circle provides meaning to the trigonometric ratios for obtuse angles. If you think back to when we did geometry and trigonometry for right triangles, all of our angles were acute inside of those right triangles, okay? When you think like SOHCAHTOA. But the unit circle provides meaning for obtuse angles, okay? The unit circle is a circle that has a center of 0, 0 and a radius of 1 unit. The equation of the unit circle is x squared plus y squared is equal to 1. The reason why it's this particular equation that's already printed is because what you see in the green is the equation of a circle, any circle that has a center at 0, 0. X squared plus y squared is equal to r squared. But because our unit circle has a radius of 1 unit, we can go ahead and plug 1 in for r, square it, and then that's how we get this equation for a circle, or the unit circle. If P is any point on the unit circle such that OP makes an angle measured anti-clockwise or counterclockwise from the positive x-axis, that is how theta is created. Okay, so when we had counterclockwise or anti-clockwise, it creates a positive angle. with the positive x-axis. So this is the angle that's being referenced. Cosine of theta is the x-coordinate of P, and sine theta is the y-coordinate of P. So what does that mean? That means any point that lies on the unit circle, to actually find its coordinates, you would take the cosine of that angle and the sine of that angle to actually get the coordinate for that point. So if the angle was 30 degrees, then to find this particular coordinate for point P, you would do the cosine of 30 degrees and the sine of 30 degrees to actually get the coordinate. Of course, you want to make sure that your calculator is in degree mode anytime that you're working with this, because our angles that we will be working with are in degree. For any angle, cosine theta and sine theta will be values that are in between -1 and +1 inclusive. Any value of cosine theta or sine theta is going to be in between -1 and +1. So you're not going to have any value that's going to be greater than 1, like 2.58 or anything like that. They're all going to be between -1 and +1. And also, cosine squared theta plus sine squared theta is equal to 1. This applies for any angle that's in the unit circle. Now, properties of periodicity. A periodic function is one which repeats itself over and over in a horizontal direction in intervals of the same length. So what does that mean? If you have a function that literally repeats the same process over and over and over again, it is known to be a periodic function. Like so. This is an example of periodic function, because over a certain horizontal length, it is the same distance over and over again, okay? It repeats itself over and over again over the same length, the same interval length. That's what makes it a periodic function. Now, the period of the periodic function is the length of one repetition or one cycle. So if I were to take this example here of the purple curve that I've drawn, the period would essentially be one cycle before the graph starts to repeat itself again. This is an example of a period. It is that horizontal length before the cycle starts to repeat. A wave, as I drew in purple, oscillates about a horizontal line called the principal axis or the mean line. So what I'm about to do is I'm about to draw that same function over again. The principal axis or the mean line is that horizontal line that the wave is going to oscillate about. So it would be technically this line right here. That pink line would represent the principal axis. Okay, that wave goes the same distance above that line that it does below that line. And then of course, a maximum point occurs at the top of a crest. And then a minimum point is at the bottom. Okay, so maxes and mins, kind of just like with quadratics. If it opens down, we have a maximum. If it opens up, we have a minimum. Same concept applies here. However, with these functions we're going to deal with, they're actually going to have multiple maximums and multiple minimums. This formula that I've written in purple, that I've typed in purple, where it says max plus min divided by 2, that is very important because that is actually how you can find your principal axis or your mean line. This formula is how you find your principal axis, AKA the mean line. You take your highest point, you add it to your lowest point, and then you divide by 2. Now the amplitude is the distance between a maximum or a minimum point and the principal axis. So here's an example. It's kind of fuzzy, I do apologize, but here's an example of a wave, okay? It's repeating the same cycle over and over again. And then we have our principal axis, which is that line, kind of cutting that curve in half. The amplitude is that distance between the principal axis and a maximum point, or the principal axis and a minimum point. Whether you choose a maximum or a minimum, it is the same distance. There are a few other key features that are highlighted in this picture. Of course, you see a maximum point highlighted and the minimum point. The one that I definitely also want to focus on is the period, okay? Remember, the period is the horizontal distance to complete one full cycle. As you can see, after this point right here, the graph is going to repeat itself. So one complete cycle, that horizontal distance is the period. Any questions?
What was the formula for the first one?
Okay, yes, be very careful. The formula for the principal axis is max plus min divided by 2. But for the amplitude, it's max minus min divided by 2. So don't get your pluses and minuses mixed up, otherwise you're going to be finding the wrong thing. So sine and cosine functions are your sinusoidal functions. Sinusoidal is the name that's used to combine sine and cosine functions together. A trigonometric function is a function which involves one trigonometric ratio. And we're actually going to talk about only sine and cosine in this class. Now, what you see here is you see a chart where you have your theta, your angles, and then you have sine theta, and you have these different values. These are essentially the coordinates of the different points along your sine graph. So you can really look at it as these are your x's and these are your y's. Theta, your angle, are your x coordinates. And then your y coordinates are what you get when you actually plug 0 in for theta into sine theta, or when you plug 90 in for theta into sine theta, and so on and so forth. But each of these points is how the graph of sine is created. Okay?
There's points like that.
Yeah, these points, but the table should be in your,
Oh, okay.
it should be in yours. There's something I wanted to say. Yes, I do remember. The ones that you need to be concerned about are those that I highlighted from the beginning. 0 degrees, 90 degrees, 180, 270, and 360. Why are these the important ones? Well, if you look at those corresponding y values, I either have 0, 1, or -1. All the other ones in between, like the square root 3/2, I mean, that's some decimal approximation. Okay, cool. But when we start doing some transformations with it, it's going to be a lot easier to do the transformations with 0, 1, and -1 than it is to be with the square root of 3/2. That's why those quadrantal angles, those ones that are highlighted on the unit circle, that's why those are the most important ones. I like to call them the big 5. So if you ever hear me refer to the big five, I am talking about 360, 270, 180, 90, and 0 degrees. Because again, their corresponding y coordinates are nice, simple numbers. Those are also the points that we're going to use when we actually graph sine and cosine for different equations that we're going to run across. Okay? So you are going to need to know these. You are going to need to know these. These are not in a reference book. You are going to need to know them. You have the graph of cosine. Again, theta is your x coordinate. Cosine x, what you get when you actually plug those angles into cosine theta, those are your y coordinates. The ones you need to know about, again, are 0, 90, 180, 270, and 360, the big five. What do you notice about the cosine graph that's the same as the sine graph? What do you notice between the cosine of theta's graph that's the same as the sine theta graph?
The shape.
The shape. They both are what?
Periodic function.
They're both periodic functions. What else is the same between sine theta and cosine theta?
The values are the same, they're just like flipped around.
They use the same y values, just a slightly flipped around. Okay. That's a similarity and a difference. Can anybody else notice a similarity between the two? Let's see if you understand the vocabulary. What is the amplitude of my sine theta graph? It's 1.
Because it'd be 1 plus -1. I mean, 1 minus -1. So that would be 2 divided by 2.
Well, remember, to find your amplitude, it's max minus min divided by 2. So like you said, that's going to be 2 over 2, which is 1. And then look at cosine. My maximum is 1. My minimum is -1. So max minus min divided by 2 is also 1. So they have the same. Very good. What is the principal axis? What is that line that's pretty much cutting the graph in half? It's 0. Okay. If you can look at the graph and recognize it, it is 0. If you can't, you could do it using the formula. That formula is max plus min divided by 2. 1 plus a -1 is what?
0.
0 over 2 is
0.
So your principal axis is 0. Look at this one. Isn't it too 0?
Yes.
Mm-hmm. And we can also do that algebraically as well. Max plus min divided by 2. That's another 0 over 2, which is equal to 0. Okay? So they have a lot of similarities. The biggest difference is those y coordinates. Even though they're the same, they actually don't go in the same order. Where's the y-intercept in sine? What's the y-intercept for the sine theta graph?
0, 0.
It's at 0, 0. But where is it for cosine?
0, 1.
0, 1. So I like to call my y-intercepts my starting points when it comes to graphing these different functions, okay? So essentially they have different starting points. Granted, that arrow is there for a reason. They continue on and on forever in both directions. But when we graph them, we're going to be basing these off of those starting points of 0, 0, and 0, 1. So again, I need you to know the big five and their corresponding y values for sine and cosine.
So cosine is always going to start at 0, 1.
Cosine will always start at 0, 1. Sine will always start at 0, 0, unless they've been translated or transformed in some way. So we kind of talked about these a little bit already. Graphing the trig functions, and we have the graph of sine x and cosine x. Y equals sine x, y equals cosine x. It could be x, it could be theta, it could be alpha. It really doesn't matter. It just basically represents an angle. The blue graph on my screen represents sine. The green graph represents cosine. Of course, you guys don't have colors, but you do have this graph. So if you want to identify one as the other, by all means, go ahead and do so. But looking at these graphs and the fact that these arrows indicate that they continue on, what would be the domain of these?
Negative infinity, positive infinity.
Very good. Negative infinity to positive infinity. And what do I put around the infinities? Okay. Throwback. Who remembers how to write that in set builder notation?
Is it negative infinity plus
X cannot equal any real number.
equal to x equals r?
It actually would be equal to all real numbers. So that is the set of x values such that x was actually element of real numbers. We did this earlier in the unit when we were talking about domain and range. So either one, IB will give it to you in set notation. But if you ever have to write the domain, you can choose whichever notation you feel more comfortable with. Now the range corresponds to how low, how high the graph goes. What's the lowest that either graph goes? What's the highest? So my range is from -1 to 1. But are those included?
Yes.
They are. Because remember, I had a max at +1, a min at -1 on both of these. So I need what around the ones?
Brackets.
A bracket. In set builder notation, this would be the set of y values such that -1 is less than or equal to y is less than or equal to 1. Remember, we use inequalities in set builder notation. We use parentheses and brackets in interval. Infinities are with interval notation. Unions are with interval notation. Just to kind of put that back into your memory. Now the period of both of these graphs, remember the period is the horizontal distance that the graph travels before it starts to repeat itself. If I look at sine and I use my starting point, I go up, I go down some more, and I go up. What's happening after this point? It repeats. So what I've highlighted in yellow is technically one full cycle. How long is it from the starting point to the end of that yellow curve? 360 degrees. So the period is 360 degrees. It is the exact same for the cosine graph. If I use my starting point, I go down some more, then I come up some more. At this point, the graph is going to start to repeat itself again, but it too has a period of 360 degrees. From here to here is a distance of 360 degrees, and that is my period. What is the amplitude for both of the graphs? 1. We talked about that on the previous page. And what is the principal axis?
0.
It is 0. It is an axis, kind of like the axis of symmetry, so it doesn't need an equation. It's y equals 0. I should have done that from the very beginning, but I'm gonna correct myself now. Principal axes are equations, so we need to write them as such. Y equals.
How did you know the axis was 0?
So we can either do it using our formula, which was max plus min divided by 2. And we can recognize that our max is 1, our min is -1, and then we can get 0 that way. Or we can look at the graph and say, okay, I need a horizontal line that basically splits my graph in half, where the graph goes above that line the same distance as it would if it were to go below that line. And so that's why 0 or y equals 0 is our principal axis. We can either use the formula or we can look at the picture and recognize. Some people can see it, others need to use the formula. So the general sine or cosine function is written like so. Y equals a sine bx plus d. That is the general form. And the reason why cosine is in parentheses is because, like, literally cosine is the same way, you just trade out sine for cosine. A is your amplitude, and your amplitude is always the absolute value of A. Those vertical bars represent absolute value. Your period is found by taking 360 degrees and dividing by the value of B. Your principal axis is y equals d, the value that's being added to that trig function. So you can pull out the actual information, amplitude, period, and principal axis from the general equation without even having the graph. Okay? And vice versa, I could find my equation from the graph by using these formulas as well. Just make sure everybody understands this, the general equation for sine and cosine. So cosine would be the exact same thing. I just trade out the sine for cosine. It's the exact same thing. Also, you don't technically need parentheses around the bx. So you really could have an equation that is y equals 2 sine 3x minus 4. Like, you don't have to have the parentheses around the b and the x, but it still is, this is still a, this is still b, and this is still d, okay?
So cosine is the one you put in blue?
Cosine was the one I put in blue. It's the exact same setup. I just trade out sine for cosine.
Is sine or cosine attached to the A?
Yes, sine as well as cosine are attached to a. So it's like a times the sine of bx, a times the cosine of bx. D is either added or subtracted on. So even if I were to write it, let's say I wrote an equation like this. This is still in a general form. It's just written backwards. -3 would actually be what? Which variable, A, B, or D? D. 4 would be, and 6 would be. So it's still general form. The green is just written backwards. You just have to be able to identify each variable. Let's try. Let's try it. Here we go. We're going to sketch the graph for the following from 0 to, I'm going to change this. I'm not going to do 720. I'm just going to go ahead and do 360. So change that on yours too. I'm going to go from 0 to 360. I'm going to graph each of these functions. Okay. Now to do this, let's pull out some important information. For A, it says y equals sine x plus 1. That plus 1 represents what variable in the general equation? Represents D. So that 1 actually represents what?
Principal axis.
it represents the principal axis. So the principal axis for this particular equation is y equals 1. And again, we know that because this is technically d in the general form of a sine bx plus d. The principal axis means that the graph has been shifted up 1 unit.
So it would start at 1.
So it would start, the starting point would actually be at 1, because normal sine, and let me write everything in. Normal sine is 0, 0, then 90 degrees, 1, then 180 degrees, 0, then 270, -1, and then 360, 0. I got every single one of these values from that table of the graph of sine x. So the black represents sine x. But to graph y equals sine x plus 1, my principal axis that was originally at 0 is now at +1, which means this entire graph has been shifted up 1 unit, which means this starting point at 0, 0 is now where? 0, 1. This point at 91 is now where? I gotta go up. I shifted up 1 unit.
92.
So it'll be at 92. This point at 180, 0 has been shifted up to 181. This point at 270, -1 has been shifted up 1 unit to 0. And then this point at 360, 0 has been shifted up to 360, 1. The principal axis is a vertical translation of my graph. So it has shifted my graph up 1 unit. And this is the graph of y equals sine x plus 1. So I'm going to draw sine x and cosine x, the original parent function, so you can see how the original graph is transformed with these different values of a, b, and d. But you don't have to do that every time. Of course, you can just take it and go with it. So the next one is y equals 3 cosine x. Well, I'm going to go ahead and get my graph of cosine in. I'm going to use that table of values to do so. So cosine is at 0, 1, 90 degrees, 0, 180 degrees, -1, 270, 0, and then 360, 1. This right here is the parent graph of cosine x. This is the graph that's going to be transformed in some shape, way, or fashion. I have y equals 3 cosine x. That 3 is which variable in the general form? Is it a, b, or d? It's a. It's that value that's attached to my trig function in the front. A represents the absolute value of A is the what?
Amplitude.
It's the amplitude. So the amplitude of this graph is 3. The amplitude represents the distance between the midline, or sorry, the mean line, the principal axis, and a maximum, or the principal axis and a minimum. So in transformation terminology, this is a vertical stretch of the graph, which means that the maximum and the minimum are not going to occur at +1 and -1. They're going to be stretched by a factor of 3. So now my maximum point that was originally at 0, 1 will now be at 0, not 4, 3, because I would multiply it to all of my y values. I'll say that again. Vertical stretches affect your y coordinates through multiplication. You multiply your y coordinates by the a value to get that vertical stretch. Now this point that's at 90 degrees, 0, I can't stretch 0. 0 is where it stays, because 0 times 3 is 0. But this point at 180, -1 will now be at 180, -3. Remember, I'm vertically stretching it. So that means it's like I'm taking the ends and I'm pulling it to the top and pulling it down. This one at 270, that one's actually going to stay the same. But then 360, 1 will be 360, 3. And when I connect all of these points, hopefully smoothly, you can see that the original graph of cosine that was in the black has now been stretched vertically by a factor of 3. So the a value in your general form affects your y's. So you're going to multiply all of your original y values by a. D as in dog, it too affects your y's, but you're either going to add that value if it's positive or subtract that value. So like in A, the graph was shifted up 1. So we added 1 to all of our y values. If it was a negative, we would have subtracted to bring it down. Now C, y equals sine 2x. That 2 is which variable, A, B, or D? It's B. B is actually going to affect your x coordinates. B affects your x coordinates. How so? Well, let me get the graph of sine on here first. What's the starting point for sine? What's the y-intercept for sine? X?
0.
0. Then it goes up to 1, then down to 0, down to -1, back up to 0. That's why the big 5 again are important. We get these nice numbers that are easy to multiply and add to, unlike the square root of 3/2. So again, the black is y equals sine x. Now to get sine 2x, that value affects your x's. Follow me on this one. If this represents B, what formula from the previous page involves B, has B in it? 360 degrees divided by B. That formula is to find your what? Your period. Your period is that horizontal distance it takes for your graph to complete one full cycle. The period of sine x is 360, but sine 2x, the period is actually going to be 360 divided by 2, which is what? 180. It's going to complete one full cycle between 0 and 180 degrees. So that means this graph is going to get squished in, horizontally shrunk So I'm gonna take the left side and right side, and I'm gonna push them into each other so that it completes one full cycle between 0 and 180 degrees. How do we do that? Well, like I said, follow me on this one. We're gonna take each of our X values and we are going to divide them by 2. Why 2? Because that's the value of B. If it was 3, we would divide by 3. It's 4, we would divide by 4. Okay? So I'm going to take each of my X values. That's my big 5. That's 0, 90, 180, 270, 360. I'm going to divide every single one of those by 2. Again, it's 2 because that's my B value. What's 0 divided by 2? What's 90 divided by 2? The next one be 90. 135. 180. Those are going to be my new X coordinates. That's going to cause me to basically squish my graph in so that I can complete a full period between in 180 degrees. Do my Y coordinates change? Exactly. No, it does not, because B affects the X coordinates. There is no A, well, technically there is 1, but 1 is not going to affect it. And then there's nothing being added, so it's not going to move it up any at all. So the original Y coordinates of 0, 1, 0, -1, and 0 stay with those new X values. So I'll be at 0, 0, 45, 1. 45 is halfway in between 0 and 90. Then I'll be at 90, 0. 135, -1. 135 is halfway in between. And then 180, 0. Then I'll connect all these points and you'll see that the graph of sine was terrible. The graph of sine has literally been squished in. And now one complete cycle happens within 180 degrees. Now, something else that I would like to highlight, because it did say the graph for 0 to 360. Right now I only have 180 graph for this new graph. Since these are periodic functions, they're going to repeat the same cycle, the same pattern. Okay? So I'm going to go halfway in between these two, and then I'll be at 1. Then at 270, I'll be at 0. Halfway between 270 and 360, I'll be at -1. And then 360, I'll be back to 0. I'm repeating the same process that I did for the 0 to 180. One special thing that's actually kind of interesting, B not only is used to find your period by using 360 divided by B, but it also tells you the number of complete cycles between 0 and 360. The B value tells you the number of complete cycles between 0 and 360. As you can see, green was 1, this yellowish tan color was 2. And I completed 2 full cycles between 0 and 360. So B also tells us that information as well. So to make sure that everybody is following along, you have X coordinates and you have Y coordinates for these different graphs of sine and cosine. X is affected by which variable, A, B, or D? B. So you technically are going to divide your X values by whatever the value of B is, okay? But your Y's are affected by which variable? A and D. So let's say A and D were involved in your problem. You would multiply by your A values first, and then add or subtract your D value. That is how those variables in the general form affect your X coordinates and your Y coordinates. Okay, so this right here that I've written down in black, this is good to know. So we're going to sketch the graph. I got two transformations in this one. 3 is A, B, or D? It's A. And 2 is B. So I'm going to have an effect on my X coordinates as well as my Y coordinates. Okay? So, and the thing is that, like, essentially I kind of got to do them like at the same time. Okay? So what I like to do is I like to make a table. One, because the table keeps everything nice and organized, especially when I start adding in multiple transformations. Because you're going to get to the point where you're going to have all 3 transformations. I'm going to take my original X values, which were my angles, the big 5, 0, 90, 180, 270, and 360. Again, this is how I like to do it, just so I can keep everything nice and clean and clear. Since this is a cosine function, I need the Y values for cosine. Y is different from sine. Cosine starts at 0 or 1? Starts at 1. Then it goes down to, and keeps going down to, then it goes back up to, and then to 1. These right here in black represent the original cosine X. These are the original points. But I want to get the new points for Y equals 3 cosine 2X. To find my new X coordinates, I have to divide all of my X's by B. So I have to divide all of my X's by 2. So what's 0 divided by 2? What's 90 divided by 2? 180 divided by 2. Keep going. Thank you. So these are my new X coordinates. For my Y's, I'm going to multiply by my A value, add or subtract D. But as you can see, we don't have a D. So I'm just going to multiply all of my Y values by, which is 3. What's 1 times 3? 0 times 3. -1 times 3. 0 times 3. And 1 times 3. So what you see in blue are the points that we need to plot for cosine 2x. Zero, 3. 90. 45, 0. 90, -3. 135, 0. 180, 3. So it's hard doing it on the board, trying to graph this. I'm looking at it at an angle. And I do have to repeat it because it says to 360. Now, the big 5 will only give you 1 complete cycle. But I should have how many between 0 and 360? I should have 2. And I know that because B is 2. B tells me the number of cycles I'll have between 0 and 360. So I need another complete cycle. I repeat the same pattern. I go halfway. I go down to -3. I go halfway. I go up to 3. And that is my graph of y equals 3 cosine 2x. Write equations of these functions, okay? There's 2 different ways that we can do this, okay? It really kind of depends on what you're given, okay? Let's actually start with the second one first, and then we'll do the other one, the first one last. So we're gonna start with this one. This is write an equation for the sine function. First off, it tells us the type of function we're gonna write, sine. So we need the general form, which is y equals a sine bx plus d. Gotta know it. That's not in your reference book. Now recall what each piece represents. What does A represent? Very good. D represents your what? Very good. And then B, it corresponds to the period. What's the formula for the period? Very good. It's good to know that because you'll need to basically decipher all of that here. Now, we do have formulas to find the amplitude in the period, amplitude in the principal axis, just in case you can't visually see it in the picture. Okay, remember amplitude is found by doing max minus min divided by 2, and your principal axis is found by doing max plus min divided by 2. These formulas are good just in case you can't visually see what the principal axis is or what the amplitude is. Okay, so you have 2 ways to do it, looking or formula. So if you can look and see, what is the amplitude going to be? What is going to be the value of A? Okay, it's fine. We'll use the formula. I need to, it would be 1. Let's use our formula. What is this maximum height? 2. What is this minimum height?
0.
So I do max minus min divided by 2. 2 minus 0 is 2. 2 divided by 2 is 1. So my amplitude is 1. Now you don't have to write 1, but I'm writing it so you guys see what it is. Let's find our principal axis. Not 2. It's actually going to be, if I do the formula max plus min divided by 2, it's actually going to be 1, or y equals 1. So D is a plus 1.
So what's the marker and minus 2?
I guess this will show the maximum height that those maxes are hitting to. Now we have to find B. Well, to find B, I need to know what my period is. How long does the graph take to complete 1 full cycle?
Is it 180 degrees?
It is, because if I start here and I go up, down, down, up, that is 1 complete cycle. So my period is 2. So I can use this formula of period equals 360 over B and plug in 2 for my period. And solve. Oh, I'm sorry. Dang. No, I gave the answer by accident. Dang, and it's on video. My mistake. The period is what was said. What was the period? 180. Sorry, I said 180 equal to 360 over B. Sorry, I got a little excited. I gave y'all the answer. The answer is 2 because if I multiply both sides by B, I'll get 180 times B equals 360. And then to solve for B, we would divide by 180. So B is equal to 2.
And it's still equal y equals.
And it still would be Y equals. And that's how we get the equation of the sine function. Y equals 1 sine 2x plus 1. Yes, you do not have to put the red 1. You can just say sine 2x plus 1, but I just wanted to emphasize it. Also, don't forget, B is also the number of cycles, number of complete cycles between 0 and 360. If I were to trace over, don't I have 2 complete cycles between 0 and 360? So then B is 2. You can also look at it that way. These are the easier ways to write the equation. That's why I wanted to do this one first. The next one's a little bit more involved. So let's look at this one. It says find the unknowns in this equation. I have a general setup of f of x equals a sine x plus d. The only problem here is that I literally only have 2 points on this graph. 1 point involves the big 5 and a maximum, but this other point is not at a minimum and is not one of the big 5. So I have 2 points and an equation. I'm going to have to use a concept from the very beginning of this unit to do this. It's going to be a system because I can take my X and my Y coordinates and plug them in and create 2 equations. So I'm going to plug in 8 for Y and then 90 for X to have this first equation. And then I'm going to plug in 1/2 for Y and 210 for X to have this equation. Now, sine of 90 degrees is a value just like sine of 210 degrees is a value. Can someone do sine 90 in their calculator, making sure they're on degree mode? It's a little dead air. It's fine.
It's 1.
It is 1. So this whole thing turns into 1. So I just have 8 equals A plus D. Then someone do sine of 210 degrees. Tell me what that value is. Negative 0.5. So this sine 210 turns into negative 0.5. So it's going to be negative 0.5 A plus D. And sure enough, I have a system of equation that I can use my calculator, that polysomalt feature that we did when we did back when we did 3-1. We can do that here. I can also solve it algebraically. Either way, okay? So for nostalgia's sake, I want to solve this using elimination. I'm going to go ahead and multiply this bottom equation by a -1, so then that way I can cancel out my D. Then I'll just add those 2 equations, those 2 lines together. 8 minus a 1/2 is 7.5, or 15 over 2. 1A plus 1.5A is 0.5A is going to be 1.5A. I'm going to divide both sides by 1.5, and 15 over 2, or 7.5, divided by 1.5 is equal to 3. Did you guys get 3 for A? No. Okay.
I got 5 for A and 3 for D.
Oh, it should be, never mind. It should
Yeah,
be-
that's what I got.
My bad, should be 5, because it's 15 divided by 3, which is 5, yeah. So then I can plug that into one of my original equations. I'm gonna use the top one. That's 8 equals 5 plus D. Subtract both sides by 5, and D is equal to 3.
Yeah.
So whether you do elimination or substitution, you end up with this, or your calculator, you end up with the same value for A and D. So my function is 5 sine x plus 3. That means my principal axis is where?
Y equals 3.
Y equals 3. And my amplitude is 5. What was B in this problem? It didn't ask, but I'm trying to see if y'all recognize it. What was B in this problem?
1.
It's 1, because it's the number that's attached to the X, and even though nothing's there, is an imaginary 1, not an invisible 1. And if the period is 360 divided by B, 360 divided by 1 is 360. So even though it didn't ask for what I wrote in the green or the orange, you should be able to pull out that information based on what we learned today, which is how to write equations of sinusoidal functions, as well as graph them.